What's up, everyone? This is LeetCode 15 3-sum. We've done this problem in Python. Now we're going to do it in C++. So we're given an integer array nums, and we have to return three triplets that basically add up to 0. And we can't use the same index more than once. That's what this is telling you, right? So for example, in this example, you can't do 0 plus 0 plus 0 gives you 0. That doesn't count. You can't use the same index. Basically the indexes have to be unique. You can't basically index I can't be equal to index j or k, and index j can't be equal to k. That's what this is telling you. Additionally, the duplicate triplets are not allowed, right? So for example, -1 0 1, that gives you 0, right, when you add those three up, but you can't also add into your output array, let's say 0 1 -1, like, oh, it's a different order so I can use it twice. No, you can't. They have to be distinct, right? The triplet pair has to be distinct. Okay, so that's what this is telling you. So yeah, let's get into it. This problem has a lot of edge cases, I will warn you. I'll try and remember to explain all of them and not gloss over them, but there is quite a few. So I will warn you. So, right, the naive way to do this problem is maybe do a brute force, right? Select this, and let's check these with this pair, this pair, this pair, this pair, right? And let's move this over and check it with this pair, this pair, this pair, right? That's like a brute force way to do it. But the problem with doing that is, like, let's say I is here, J is here, and K is here, right? And you're moving K along in this iteration, right? You're moving K along, right? Whoops. Right? The problem is, like, when you move J over also, and you're doing K for all these, we already checked this pair, right? Like, we're doing I plus J plus K, but technically when J was here and K was here, we're checking the same pair, right? So the problem with this is you're adding overhead where you're potentially checking pairs that you already checked. And additionally, if they add up to 0, you need to make sure that pair is not already in your output array. So how do you even check that? That's just a lot of messy code, and you're adding overhead. Like, this is just not a good approach, okay? And you'll come to that realization pretty quick when you try and do it the brute force approach. So what do we do? Okay, well, let's handle this, right? I can't delete that, deletes the whole thing, whatever. So look at this input array. What do you notice? Well, you might notice that, well, we have a -4 here and a -1 here. That's pretty weird. Why don't we try sorting, right? Now, when we sort, it makes this problem a little bit easier, okay? Because basically the gist of this problem, the trick to this problem, the neat, clever thing to this problem is we're going to set an I here, and a J is going to be set one to the right of the I, and the K is going to be set at the end of the array, okay? And we're going to add these up. In this case, we'd get -3, right? -5 plus 2 gives us -3. And we have three conditions, right? We can get a number that's 0, a number that's greater than 0, positive number, or a number that's negative, less than 0, right? In this case, we get a number that's less than 0. So the way we handle this problem is, well, if we have a number that's negative, can we make it bigger? Yeah, we can move this over, right? Because you see when I'm moving this over, we're getting bigger and bigger numbers because of the fact that we sorted, right? So if we have a negative number, let's move the left pointer over to the right. If it's positive, let's move the right pointer over to the left to make it smaller. And we need to make sure we don't use duplicates, right? So when we move this over, right, we're gonna have the same problem. We're gonna get -3. Let's move this over. We get -4 plus 3 gives us -1. Not good enough. Okay, -4 plus 3 gives us -1. Or sorry, this gives us -2. I don't know why I said -1. This gives us -1, but still too small. Boom. Okay, the left pointer and the right pointer. The left pointer, when I say left pointer, I'm referring to J. Right pointer refers to K, right? Because the I is stationary. So when the left pointer is not less than the right pointer, we have to move on. Meaning we have to shift the I over and just start over. Why? Because we can't use the same index, remember? So this would be a problem. So, okay, we reached basically all our combinations. We found nothing. So let's move this over. And when we move this over, well, I'll explain it in a bit. Okay, so move this here. Again, j 1 to the right of the right. J is 1 to the right of I, k is at the end. Let's check this pair, okay? And let me delete this, by the way. -1, -1, and 2. Okay, that gives us 0, right? That's pretty good. Let's add that to our index, or our output array, sorry. Okay, because this is example 1, by the way. -1, -1, 2, pretty good, right? So what do we do in this case when we encounter a number that is equal to 0? We want to move, well, let me just preface by saying this, right? We have a number that's equal to 0, right? So why do we want to move the left pointer over when we know we're only getting a bigger number? We already have a 0, right? We already have a 0. So why do we just want to keep moving this over? Isn't that just kind of inefficient? Yeah, so let's move this over, but let's also move the right pointer over so we get a completely new set of distinct numbers, right? So move this over 1 and move the k over 1. But when we do that, we need to make sure we don't have the same number. Meaning, let's say this 0 was a -1, and we move this j over. We're at the exact same scenario, -1, -1, and k, right? So let's move the j over until we have a number that's not equal to where we just were, okay? And the same logic would apply to k. Move backwards until our number we just were to a different number other than the one we just were at. Because, for example, we could have a 2 here, and we don't want to move k over because, again, the reason we do this is we want, again, distinct pairs of triplets. So we have to do this to avoid any potential issues, right? So now in this case, we don't have any of those issues, right? Because these are different. But so we'd move this here, we'd move this here, and we would get -1 + 1 + 0. Interesting, right? Because that adds up to 0, right? -1 + 1, that cancels out to 0. We add 0, that gives us 0. So -1, 0, 1, and again, that's also an output, right? So let's do it again. We found a pair that's equal to 0. So move this over, move this over. Okay, now the left pointer is not to the left, but actually to the right of the right pointer. So we have to break. Okay. We have to break. So we have to handle the I now. Now, here's where we have an issue. We could move this I here, but we would get, if we set the j here and the k here, right? We get a number that is too big, right? So we move the right pointer over. So we would get k here, and we do this. Well, we already have that up here, right? So we have a duplicate, which is a problem, right? But remember what I said, we want to avoid using the same number. So we actually would never have this problem if we handle this properly. And the way we handle this properly is, when we move I over, if it's the same number as the previous element, where we came from, just keep moving over. So for example, we're at this -1, we're moving I over. Oh, this is also -1, so let's actually skip it. Boom. Now we're talking, right? We actually can avoid that problem entirely. Okay, so let's set j here, let's set k here. 1 + 2 gives us 3. That's too big of a number, so we have to move the right pointer. Boom. Oh, at the same index, right? The left pointer is not less than the right pointer, so we have an issue. So again, move the I over, right? And again, same index, we have a problem, right? So we actually basically go through this entire array, and this is our output, and that's what we expect, right? Okay, so pretty good. So how would we do this in code? And by the way, sorry, I forgot to mention this. We actually wouldn't check here at the end. We wouldn't do this, right? We actually wouldn't even check here. Now, why would we not check here? Is because we're going to have a condition that's going to break our loop, which is if I is at a positive number, we're just going to completely stop the program, okay, and return our output array. Now, think about it. Think about it. Why would we do that? Well, this is sorted, right? So if I is positive, j and k are never going to be negative because they're to the right of I, right? The way we set these pointers is such a way that j is to the left of I and k is at the end of the array. Even if this array was super long and they didn't overlap, we still wouldn't check this, right? Let's say this was a 7 here. We still wouldn't do this because if I is positive, right? If I is positive, why the heck would we want to check this 2 and this 7, right? In what world would we get a 0 if I is positive? we would never get a 0, right? Because we're adding a positive integer to even more positive integers. We'll never get a 0. We'll never get a 0. So if I is positive, just break, right? Just break. It's kind of pointless. Okay, so that's also another edge case we need to handle. And again, there are ways to make this. You can write solutions that are a little bit more sloppy, but this solution is like a hyper optimized solution that's meant to be super efficient, and you handle a bunch of edge cases so you avoid any sort of repeating work or anything. So that's kind of the point of the solution. So first of all, remember what we did at the start? What did we do at the start? We sorted, right? We sorted the input. I'm going to say this. Okay, right. Okay. So here, if the current number is positive, we can stop. No positive sum can be 0. Okay. We're going to say if num greater 0, break. Right? And sorry, we have to actually calculate num. So we're going to say num is equal to nums of index. So, so num is really nums is really nums of I, right? Index is really our I, okay? Just so you're a little bit clear on what we're doing. Okay, so we're gonna handle this edge case where if we have a positive I, right, after we sort, just break. We're never gonna get a 0. We also can we also have to skip duplicates for the current index. So if index is greater than 0, and the current index that we're on is the same as the previous index, right? That would be a case where we just move on, right? Because again, remember, like we would never ever want to check this against this, and also check this against this and this. We don't want to handle duplicate triplets, right? So this kind of avoids that by moving the I over, and we're gonna have to do the same for J and K, right? We'll do that later. So let's set our L, and again, our L is 1 to the right of the index, or I, right? Wherever I is. So we're going to say index plus 1, and again, the right pointer is at the end of the array. I'm going to say nums.size minus 1, right? While left is less than right, right? Now, this while loop is basically, we have a specific I, and we're handling something in here, okay? That's what our while loop is doing, okay? So we have an L and an R, right? So we have an I, an L, and an R. So we have a nums I, nums L, nums R. Let's, or nums J, nums K, right? So let's find what they add up to, okay? Because we set all our pointers, right? So we're going to say num plus nums of L plus nums of R. That should give us something. And again, we have 3 possible conditions, right? Negative number, 0, or a positive number, and we need to act accordingly depending on which one of those 3 conditions we're in, okay? So if we have 3 sum that's equal to 0, then, right, I don't know. I always put my code bases on their own line, just the way I program C++. I'm sorry if that annoys you. So we found 3 numbers that add up to 0, so let's basically just put that in our output array. We're going to say this, right? We need to add the pair, so we're going to say num. And again, we're adding the actual numbers, not the indexes or anything, so keep that in mind. Nums of R, right? Pretty good. We're going to move the left pointer, the right pointer, or sorry, the right pointer goes back. And we're going to say here, basically, we have to skip duplicates for L. I'm going to say while left is less than right, and nums of L. And again, right above this line, we move the pointer over, right? So we can just say if nums of L is equal to nums of L minus 1, because we move the left pointer over to the right, right? In that case, let's just keep moving it over, right? Then down here, we skip duplicates for R. So we're going to say while left is less than right, and nums of R is equal to nums of R plus 1, because we're moving the right pointer over to the left, right? In that case, we're going to do plus R, or sorry, not plus R, minus R. Okay. That's the if statement. We're going to do else if, right? 3 sum is less than 0, right? If we have a negative number, let me move this down. If we have a negative number, remember, we want to move the left pointer over because we want to get closer to 0, hopefully, and actually hit 0. Well, not closer to 0. We want to get 0. So if we have a negative number, how do we make the sum more positive? We have to move the left pointer over because, again, this is sorted, so we're adding more positive integers. Okay, so we move the left pointer over if we have a negative number. So we have a negative number here, so let's move the left pointer over. Else, right? Basically 3 sum. Basically 3 sum is greater than 0. So if we have a positive number, how do we make it smaller? The right pointer has to move to the left, right? Okay. And then make sure you return your answer, and there you go. Okay, I forgot to do int, my bad. There you go. See if this goes. It does. And that's a problem. A lot of edge cases. Not an easy problem, to be honest. This is because of how many edge cases there are. This problem is a little bit on the harder side of the mediums, in my opinion. There's a lot of other people who have done videos to this problem, and they generally agree. This problem is a little bit tricky. Because there's different, like, this is, like, I did a few optimizations here, like here and here, right? Like, there's a lot of ways to approach this problem. Some more efficient than others, as well as there's a lot of edge cases, and knowing that you have to sort to begin with to make this problem viable or approachable is, you know, not easy to come up with on your own. Additionally, like, we have an O of n squared solution. Like, you know, like when you have a problem where it's O of n squared as the most optimal choice, it's probably going to be a little bit messy, right? I definitely struggled with this problem when I came upon it, and I mean, acceptance rate 35%. Like, this is not an easy problem, so don't feel too bad if you couldn't solve it on your own. I'll be honest, you are pretty dang good at LeetCode if you can solve it on your own without help the first time around. Certainly wasn't the case for me, but anyways, I hope this helped. I know this video is a little bit on the longer side, but I just want to be methodical in explaining things, making sure it helps. If anything about this problem is a little bit confusing in terms of my explanation, feel free to watch this same video, but the Python version that I made, because, you know, Python code's a little bit more simple, right? You have a little bit more leeway, whereas, you know, C++ is a little bit more strict. So, you know, feel free to check out the Python video. Maybe it'll help you understand it in Python a little bit. Watching the Python video might help you understand the problem itself, and then you can focus on the actual syntax that you need for this problem in C++. But yeah, I hope this helped, and I'll see you in the next one. Peace out.